Welcome. My name is Emil Lurch. I'm a principal DevOps specialist with AWS. Today, I'd like to talk to you about writing, deploying, and provisioning cloud resources with AWS developer tools. Today, we'll be taking a day in the life of a developer from front to back, from the time that she looks at an issue that's been reported to the time that she reproduces that issue, fixes that issue, writes a test for that issue, and deploys that issue into production. She'll be doing all these using AWS developer tools and without leaving her IDE. But the AWS developer tools will also be assisting her in terms of building, testing, and deploying her code as it needs to get into production. This will all be done in a demo where I'll actually show you the IDE that she uses, the code that she writes, and the tests that she writes, and also show you a little bit about how that behaves behind the scenes. Lastly, we'll talk a little bit about some of the alternative ways that she could approach the problem with different tools that are provided by AWS. So let's get started. I'd like you to meet Kate. Kate is a programmer, developer working with her business, developing applications to be able to push her business, move her business forward. She wants to focus on the algorithms that are really going to be providing the most amount of business value without having to worry about some of the ancillary things that are critical for software development, but not important for her specific role. Things like being able to do security scans of dependent libraries, making sure that all the regression tests continue to pass, unit tests and integration tests for software that may have been built by another developer. These things are obviously very critical, but not something that she really wants to focus on. What she needs to focus on are the tasks that she's captured as part of her job for today. So in order to help assist Kate with her job, we really want to look at a few different key performance indicators, both for Kate and for the rest of her team. We want to look at things like deployment frequency. Deployment frequency is important for Kate's team. As Kate makes changes and the rest of her team makes changes, we want to make sure that all those changes can go into production as quickly as possible. And the way to do that is to parallelize our deployments and have a really high deployment frequency. So we will be watching that metric in detail as the team develops the application. Lead time for change, however, is going to be extremely important for Kate specifically. She wants to be able to write her code, provide a git commit command followed by a git push command, and then go hands off and let the rest of the system move that code from what she's authored into production as quickly as possible. She would rather wait just a minute or two rather than waiting an hour or more to be able to see the effect of her code changes make it into production. So lead time for change is something that's going to be super important for her. Time to restore service. So in the event that Kate or another member of her team might write a code that has a bug in it and might take the service down, we want to be able to restore that service quickly. Or maybe there's an attack happening from the outside. A hacker has found a vulnerability that they can exploit. We want to be able to restore that service as quickly as possible. That's going to be mission critical for Kate's business, and so we want to measure that and keep a really good eye on that particular metric. Lastly, change failure. I mentioned that Kate might make a mistake and introduce a bug, or another member of her team might introduce a bug. We obviously want to minimize that change to the extent that we can. That's going to rely on a lot of automated testing and additional things that we can do in the pipeline, things like security scanning that are going to minimize the amount of change failure that we see within the system. What we want to do is really make sure that Kate can get a sense of flow. For a developer, a sense of flow is key to being able to be the most productive that they can be. Much like a kayaker going down a stream body of water, We want to be able to focus on where the kayak needs to be within our stream. How do we avoid the rocks as we go through, and how do we find that most efficient path to success? For a developer, we want to be able to do that with our code, make sure that we avoid the rocks and find our path to success. So getting into that sense of flow, eliminating distractions so we can only focus on the things that matter as we're deep in thought, thinking about new innovative ways of developing our algorithms and to make the application behave as best as it can with the most amount of features and performance. We want to really focus in on how do we allow our teams and individual developers to get into a sense of flow and stay there as long as possible. I'll come back to the sense of flow over and over again throughout this presentation as we go through the demo and we show how Kate can stay within her IDE. Kate's going to first author. As we look at the entire development process overall, it all starts with authoring code. Kate today will be using VS Code, but we can also use other IDEs like AWS Cloud9 or Eclipse, Microsoft Visual Studio, or any of the JetBrains products to author our code. Once that code's authored, we need a place to store it. We might have dependent libraries that are stored in an artifact system somewhere that are used to be able to build a total application. We're going to need to build that code, and then we're obviously going to want to test that code. We might use our own testing frameworks, or we might use third-party frameworks to do the testing. Once the testing is complete, we'll need to deploy the code and then monitor it in production. As we see changes happening in production, we're going to want to react to that and bring that into our next iteration of development. And so that monitoring piece is going to be critical. There's a lot of moving pieces here. As we store the code, build the code, test the code, and deploy the code, we need a way to monitor that entire process and orchestrate it. And that's where we can use tools like AWS Code Pipeline to be able to observe that process. As we write code, we're also reliant on certain infrastructure. AWS providing a lot of infrastructure, it needs to be synchronized with the code that's being written. If we have infrastructure that's out of sync, we're going to see a lot of errors and failures in our application. So we want to be able to model our infrastructure as code and store it right alongside the code that we're writing. In order to do that, AWS provides CloudFormation, which provides a declarative model using YAML files or JSON files to have a static declaration of what we want our infrastructure to look like. If we have a serverless application, we might want to abbreviate the amount of text that's in that file by using the serverless application model to assist us in describing a serverless application. And then lastly, Kate today will be using the AWS CDK. This allows her to actually describe infrastructure as an imperative in an imperative way, using the programming language that she's familiar with to be able to provide things like conditionals and loops to describe her infrastructure in a very succinct way that can then turn around and synthesize into something like a CloudFormation template. There's a lot of tools here, so we want to make sure that those tools actually blend into the background and let Kate focus as much as she can on the authoring side, and that's what we'll show in the demo. One of the ways that we're going to do that is by allowing Kate to inspect her environment and to actually interact with her infrastructure without leaving her IDE. The way that we do that is with an AWS toolkit. AWS toolkits are available for Visual Studio Code, which is what Kate will be using today, Microsoft Visual Studio, any of the JetBrains family of products, and Eclipse. In addition to the toolkits, the application that Kate's writing is actually going to be using AWS directly. The application that she's writing is using DynamoDB, which is another AWS service focused on key value storage of data. Now, Kate could actually just code against the HTTP APIs that AWS provides. She can look up the credentials, the AWS access key and secret key. She can use that access key and secret key to calculate a signature, to put the correct HTTP header on the call that she makes through HTTP, and then account for any kind of internet hiccups or blips that might occur that might make her need to retry that operation. If she's being retried because of a rate limiting issue or certain other issues that can occur, she'll want to retry by applying exponential backoff and applying jitter to those retries as she goes through. That's a lot of work, and we want to take that undifferentiated heavy lifting away from Kate so that she can focus on the algorithms that are so critical to her business. So AWS provides a number of AWS official SDKs that provide those types of features and also match the style of the language that she's working in. If Kate were using Java today, the AWS SDK, in the event of a failure, would raise an exception, and she could handle that the way that she would expect to handle it for any other class in Java. Today, Kate's using Golang. And so with Golang, there are no exceptions. Instead, an error is passed back as part of the return value. And then Kate can inspect that the way that she would expect to handle an error in any other Go SDK for anything else. So the AWS SDKs are trying to match the style to make things fluid for the programmers in that particular language. So you can see we have a lot of breadth of support for different languages. In addition, we're adding support for Kotlin if you have Android development, Swift if you have iOS development, and Rust if you're interested in the memory safety features that language provides. Beyond the SDKs, Kate might also want to inspect her environment using some command line tools. And to that end, we have the AWS command line interface. Version 2 of this interface supports Mac, Windows, and Linux. And we also have the AWS tools for PowerShell, which support the same operating systems as PowerShell itself. Again, matching the paradigm of PowerShell so that the way that you interact with AWS is the same way that you would expect to interact with anything else in PowerShell. So the CLI, as we'll see in the demo, is actually used to inspect the environment. You can modify values, modify your infrastructure directly. Of course, we want to do that through the modeling language and infrastructure as code. But if we did have that need, we could do so through the CLI. Today, Kate's just going to use that to inspect the status of her deployments. So with that said, let's jump into the demo and see what things look like for Kate's day. So at this point, Kate has pulled an issue from her backlog, as I mentioned. And the issue is around a microservice that's been written in the application that doesn't seem to be taking apostrophes correctly. Any apostrophe that's entered in by the user is somehow converted into a space. So we want to take a look at this. I've opened up the code here. The code has been written in Go. This is a Lambda function. And so let's take a look at the Lambda function quickly. In AWS Lambda, when working with Go, you'll have a main function that introduces lambda.start with the function that will be the handler for that Lambda function. That handler will be executed every time that somebody calls the Lambda function. If we look at the top, we'll see that we have the Lambda import here from AWS Lambda. And we'll see that we're using the AWS SDK. We'll get into a lot more detail here in a little bit on that piece of it. But let's take a look first at the issue at hand. To do so, we'll want to actually run the Lambda function in the environment to reproduce and make sure that the issue remains valid and repeatable. So we'll use the AWS Explorer here. This is part of the AWS toolkit for Visual Studio Code. As I mentioned earlier, this is an additional extension to Visual Studio Code that allows us to inspect the environment. We have an AWS Explorer here on the top that provides a view into the AWS environment. In this case, we're looking at US West, the Oregon region, for all of the resources that we have. We're looking at AWS Lambda, so we'll want to take a look at that Lambda, and it looks like this is part of our project. So at this point, we can do a number of different things. We can actually upload code to Lambda. We can copy the name or the ARN if we want to bring that in and reference it within our project. Hovering over it shows the same kind of information. We can actually delete the Lambda function if we have permissions. In this case, we want to invoke the function on Lambda. Now that brings up another window also provided by the AWS toolkit. And we can actually type in some payload data. This would be input to the Lambda function. To help us with this process, we can actually use a sample request payload. If we, for instance, were using API Gateway, we might grab the API Gateway AWS proxy, which will provide us with some sample data as though it were being generated from API Gateway. And at that point, we could just make the necessary modifications. This particular Lambda is not using API Gateway, but we're just calling it manually. So we'll go ahead and type in, actually, maybe we'll use the hello world. There's a handy hello world option, which we can use. It brings us a couple different key value pairs. We only have 2 in this case that we're interested in. The Lambda function takes in a title and content, and we're interested in apostrophes. So we'll use I'm a teapot with content foo, and then we'll invoke it. So on the bottom, we actually see the AWS Lambda output. This is again provided by the AWS toolkit. We'll take a look. We've got the start and the end. Everything between here is actually values that are being added by logging functions within the code. We'll see this in a little bit. And we'll see that the title here is turning into I'm a teapot without the apostrophe. And the payload here also comes back without the apostrophe. So great, we've reproduced the problem. If we were interested, we could actually see other logs from the same Lambda function by going into the CloudWatch logs. And we could actually view this log stream. We could pick the today's log stream. Okay, there we go. And that log stream shows us the same data. We might want to use the CloudWatch logs, however, rather than invoking, or instead, in addition to invoking the Lambda function, because we might want to see actual production data that's coming through our system. So we can invoke the Lambda functions right here without leaving our IDE, and we can view the logs from production also here without leaving the IDE. It's pretty handy, but we've been able to reproduce the issue. Let's actually save this to our clipboard because we'll want to test this again later on. And before we jump into the code too much, let's look at the tests. Being good developers, we're writing tests first. So we've got this test put note. Looks like we have a put item mock here, which we'll talk about in a little bit. But first we want to write a test so that we can reproduce the issue.
Let's copy this test. Change the created. We'll expect this to come back as 3. Put in I'm a teapot. Content foo. And we will want to expect I'm a teapot to come back. So this is very similar to most tests that you would write in Go, where you'd have a test structure array that just has your tests, and then later on you'll want to loop through that particular range of tests and make sure that all the tests work as expected. This particular Lambda function is working with DynamoDB, so we want to make sure that our unit tests are self-contained. We want to be able to make sure that we can run this on a plane or anywhere else that doesn't have internet activity. We want to make sure that we're not dependent on other services, and that will give us the most consistency in terms of actually writing the tests. So what we'll do is we'll actually mock DynamoDB, which means to have a dummy function there that responds as though it were actually DynamoDB. That's what this mock put item here is, this particular function. And then we'll pass that in as context into our put note function. And that will allow that put note function to utilize that mock later on. We'll see that code when we get to the main function, but for now, let's run the test without saving the file. Make sure that nothing is already broken before we've touched it. We'll do a go test, which is the standard way of doing go tests. Everything pass. So now with that new test written, we will save this test and we'll run go test again. And we have a failure. This is what we expect to have as we start out. So Kate will see here we have expected I'm a teapot with the apostrophe and an actual I'm a teapot without the apostrophe. So this is a good thing. We've been able to reproduce the issue against the live service, and now we've been able to reproduce the issue in a unit test environment. At this point, we can go into the code itself and see what's going on there. So this is your typical Go function or Go program. We have a number of imports here. We're importing the AWS SDK to be able to talk to DynamoDB. In order to do that, we need to have a number of types that DynamoDB uses to be able to add input into our service calls. And then some basic things like the AWS and the configuration. This will allow the SDK to go and look for things like our AWS access key and secret key in a manner that's consistent with how all the AWS SDKs work, as well as the CLI and the tools for PowerShell. So we have our note, which is part of the application. And then we have an interface. This put item interface mirrors the put item call in the AWS SDK and allows us to do that mock testing that I talked to before. The put note function itself does the heavy lifting for AWS Lambda. This is our AWS Lambda handler, and this is also the function that's under test. You can see from the AWS toolkit from VS Code, we have a number of logging statements that show up in here. The first one is the context that was passed in. You can see that being printed out here just with a log.printf function call. That anything that is sent to the standard output is reflected in the AWS Lambda logs. So this log.printf is simply outputting to the context to standard out, and then we'll see that show up in the logs. We'll load up the default configuration, which will prepare the AWS SDK for operation. And because it works like any other SDK for Go, we'll want to check that error value that comes back and see if there's a problem. If there is a problem, we want to reflect that in terms of a panic. Now that's okay, even though the program will die at this point. The AWS Lambda runtime will detect that issue, will raise an error back to the caller, provide the necessary context, and then rerun the program on the next invocation of the Lambda function. This allows us a way to just work with Go programs the way that we would normally expect to work with them, and let AWS Lambda runtime kind of handle that heavy lifting. So there are three pieces of data in our note: a title, the content, and the created time. If the created time was not passed in, we want to set it, and we'll just set it to the current UTC time. And then we want to actually put the item into DynamoDB. So first we need a DynamoDB service, which we will accomplish by using this new from config call. And then we want to worry about whether or not this was being called from a unit test. If we call it from a unit test, we don't want to actually call DynamoDB directly. We'll use the DynamoDB object that's being passed in from context. But if not, then we'll use the live DynamoDB service. And then the meat of this function is really in terms of this this particular put item call. So this is the DynamoDB service. There's a put item function on DynamoDB that will want to take in the values that you want to add into DynamoDB. Now, DynamoDB is a key value database where you can set a number of attributes to various values. There's a handful of types that you can use. Here we're using string types and number types. And the first thing that we'll need to tell DynamoDB is what is the table name that we want to use. So we're just using this particular table name. Of course, we could pass that in through environment variables. In this particular case, we know what it is, so we'll just code that in. And then the item that we want to add into DynamoDB. That will have a what's called a partition key and a sort key that are mandatory attributes, and they're defined on table creation. Here I've named the partition key PK and the sort key SK, and we're adding in the event title for our partition key and the created time for our sort key. That way, if we ask for a particular note title, we'll get back all the notes with that title ordered by creation time. And then the content. You'll notice that the sort key here is actually a number. Attribute value member n is telling us that, or telling the SDK that this is going to be a number that's being passed in to DynamoDB, and so that DynamoDB can identify that appropriately. Again, because this is a Go language, we would expect any call that can return can produce an error to return an error as part of the function call. So we'll inspect that error and again panic if we have any issue. And then we'll go ahead and reflect some additional logging data. So we'll print out the attributes if they exist, and then the actual note title and content as we have expected to set that into DynamoDB. So with that quick tour through the code, we want to see what might be wrong with it that's causing this apostrophe issue. Kate's going to look through this code and she's going to notice that there's this prevent SQL injection. Well, DynamoDB isn't using SQL. It uses different language to interact with it. There are, of course, ways to interact with DynamoDB through SQL by alternative means, but we're working directly with DynamoDB. And so this is a little bit suspicious. So let's take a look at this sanitize input. If we scroll down, we'll see the sanitize input function here. And there's a comment here which makes us even more suspicious. Sanitize from PostgreSQL injection attacks kind of implies that this code might have started from Postgres and then later on moved to DynamoDB. Looking at this, we'll see a bunch of different SQL statements and Postgres specifics. So this really doesn't look valid at all. So let's take a look. Since we're under source control, it doesn't hurt us to delete this function. So let's delete it, which means we'll also need to delete the calls to it. And then because we're operating in the Go programming language, it will not be happy with us trying to compile with imports that aren't being used. So we'll remove these two imports as well. Let's save the function and run our tests and see if that fixes the issue. So at this point, Kate is going to run the tests. We see that the tests pass. And so now the next thing to do is let's go ahead and commit that and push it out to the source control. So at this point, when Kate issues the git push command, what she should expect is that the servers behind the scenes are going to be looking at that code, doing sanity checks on the code, running tests on the code, building it, testing it, and then deploying it without her having to do anything. So we'll do a git push and see if that actually happens. So what we want to see is when we go back and we invoke our Lambda function using the AWS toolkit. I think I still have this in my clipboard, and I do. Oh, look at this. We have a Slack notification that says we've actually started a new pipeline execution. So that's good news. That tells Kate that the change that has been detected and is now in the process of being built and tested. So we wouldn't really expect this to already be out in production. So let's go ahead and invoke and just see. Yep, it looks like we still have the problem. That's still to be expected. Now we can wait for the next Slack notification to tell us that things have succeeded, or we can use the AWS CLI to take a look at the last modified date on that Lambda function. We'll do that by issuing an AWS Lambda list functions call. And we'll see that our Lambda function has the last modified date from a couple days ago. So clearly this has not been updated yet. Now Kate doesn't need to do anything here other than wait, maybe get a cup of coffee, or go take a look at what else might be on the backlog for her to look at next. But let's actually take a look at the AWS console to see what's going on behind the scenes. We'll take a look at AWS code pipeline. Now this is what I showed on the previous slide that actually orchestrates and observes everything else that's going on. You can see here that we're actually in the process of doing something. We see that we picked up from source a minute ago. We did the build. We're in the middle of this self-mutation thing, which I'll talk a little bit about later on. And then we'll actually create the code or build the code, prepare the Lambda function for update, and then go ahead and update the Lambda function. You can also see here CodePipeline is doing its job by not only properly observing, but we also see that we have the actual git SHA of the change that was made, and our comment here, which was to fix apostrophe issue. This was 5C540AE1. So let's take a look and verify that if we do git log -1, we'll see 5C540AE1. And that matches, that short hash matches. So that's good. We have full traceability throughout the system. Now it looks like we've proceeded a little bit further down. You can see this is, okay, our build has now succeeded. And then the CloudFormation will be responsible for actually pushing out our Lambda function. We'll see our last modified date has actually changed. The full pipeline hasn't quite finished yet, so we'll expect a Slack notification to show up in just a moment. But because our last modified date has actually changed, let's go ahead and invoke the Lambda function and see if that has been addressed. Sure enough, our title now has an apostrophe. We can see that here and here in the payload. So it looks like the problem is addressed. If we weren't watching super closely, we could, of course, just wait for the Slack notifications, which should show up in just a second. But let's take a look at what's actually happening to create all this. So I mentioned earlier that Kate is actually using CDK. That's the AWS Cloud Development Kit, and allows folks to create infrastructure in the language of their choice. You can use a number of different languages to be able to create infrastructure, and then when you issue the CDK commands, it will turn that code that's been written in your language of choice into a CloudFormation template that can then be run by CloudFormation. When we first set that the CDK up, we'll run a CDK command that again uses CloudFormation to create a basis for deploying other CloudFormation templates within the environment. So this CDK toolkit is simply run or is created by the CDK bootstrap command. That's a one-time operation. The other one-time operation that we've done is the Slack notifications. It has to have authorization for AWS to talk to Slack, and so that authorization is set up manually. Those two things are manual, and outside of that, and the initial CDK deploy, everything else will happen through the pipeline that I just showed you. So how is that pipeline defined? If we go back to the files in the project, we'll see our main application program, the tests that go along with the application, and then the CDK folder. Within the CDK folder, this was created by issuing a CDK init command. We'll see a number of different directories in here. The lib directory is the most interesting to us because it actually provides us with the files necessary to describe our project. It all starts here with the project stack, and the project stack consists of 73 lines that describe pretty much the entire stack for Kate's application. all told, if you add in the project stack, the Lambda stage, and the Lambda stack files, they consist of about 130 lines of code, and we'll see what that turns into in terms of CloudFormation template moving forward. So this is a TypeScript file. We're using TypeScript here. The CDK for Go isn't quite ready for production yet, but it is available in a preview at the moment. But I wanted to stick with languages that are in production. TypeScript is a great language to use for the CDK because the stack traces are all done in the native TypeScript language. If you were to operate CDK in other languages, the technology that it's using to do that is called JSII, and the stack traces will be produced to you in a JavaScript format, which can be a little bit off-putting if you're used to seeing stack traces in your native language. Also, there's more examples available for TypeScript, so I stayed in TypeScript for this this particular demo. So and there's our Slack notification saying that the pipeline execution has succeeded. Okay, so taking a look at this, the pipeline itself consists of a number of different stages. So let's take a look at the pipeline, and we'll see we have a source stage, a build stage, an update pipeline stage, and the Lambda stage itself. All of the stages, with the exception of the Lambda stage itself, are described with these 6 lines of code. By using the new code pipeline, this is the CDK pipelines, which is in CDK parlance, this is called a level 3 construct. This is a high-level construct that involves a lot of the details. It provides a lot of the details on your behalf. You can, of course, get in and change those details, but by and large, things are set up along the lines of best practices that work for most customers. The synth stage is part of the CDK. CDK synth is the command that we use to turn our code into CloudFormation, and the reason that we want that in our pipeline is because we want to be able to self-mutate. So if we're writing code here in TypeScript, we don't want to leave our IDE. We want to allow Kate to stay directly within that IDE. So Kate would go ahead and make whatever changes that are necessary to the pipeline itself. She would commit the changes and push the changes, and then the update pipeline stage, as we see here, has this self-mutate that will take a look and say, hey, something has changed with the pipeline itself. Let's change the pipeline and rerun it right now so that we get the latest, most up-to-date version of the pipeline pushing our code into production. That's all done with this 6 lines of code. What we do have to add is the Lambda stage itself. We want to make sure that the Lambda is described and is being published. So we'll do this through the Lambda stage, which will open up here. And the Lambda stage is simply creating a new CloudFormation stack with this Lambda stack. So let's take a look at the Lambda stack where more interesting things happen. To be able to create the DynamoDB table, we instantiate a new table. We need to provide the table name, the billing mode, what happens on removal. If the table were to be removed from the system, what do we want to have happen to it? We can either retain or destroy it. In this case, we're going to destroy it. And then I mentioned those mandatory attributes. DynamoDB needs to have a sense for what the partition key and the sort key are going to be. So we'll define those things here. The Lambda function itself needs to be defined. So we'll create the Lambda function, specify that it's a Go function with fairly small memory size, and a short timeout. And timeouts are important in Lambda because we want the timeout to be long enough that it can do its work, but not too long that we're wasting time in the event of, um, some sort of issue that might hang the Lambda function. We want to be able to short circuit that and cut it off right away. And then we need to be able to specify where the code is actually going to land. We'll talk about this a little bit more in a minute, but that code is specified as part of a bucket. The Lambda needs permissions to be able to do things. In this case, we want to be able to talk to DynamoDB. So Kate specified here that we want to be able to get item, do a get item call and a put item call on this particular DynamoDB resource ARN, which specifies just this particular table is the only thing that Lambda is uh, allowed to do get item and put item on. And then we need to be able to add the policy to the role that's attached to the Lambda function. So that's pretty much it for the Lambda definition, but we want to actually be able to specify the build commands as well. So taking a look back on the project stack, we have this Lambda stage that has the build function. We're going to echo out the environment, do a go build. We disable cgo, which will make the resulting executable a little bit smaller. And then we want to be able to have full traceability throughout the system. So the code build resolved source version, which is that SHA that I mentioned earlier. That source function, that source version is also defined in an environment variable that we can use later on. We're going to make sure that that version is attached inside the function zip so that we can download the zip later and see the version that has been assigned, the version of the source code that corresponds with the executable. We'll copy that out into S3. Into a versioned file, and then also to the latest file that which is where Lambda will pick it up from. And then we'll specify in S3 again where the version is that we can look it up in terms of the latest function actually resolves to this version. Lastly, we do an update function code, and this is an interesting part of the process because if CloudFormation sees that everything is the same with a particular template, then it doesn't need to do any work, and so it will say, okay, the update's great, we're done here. However, with Lambda, you might have changed the code without actually changing the template, which is exactly what happens here under most circumstances. So this update function code does the hard work of updating the actual function code. But if the Lambda function doesn't exist yet, if this is the first run, this particular AWS CLI command will fail. And so we add the or true onto it to make sure that the build succeeds. And then at that point, CloudFormation will be responsible for creating of the Lambda function and inserting the necessary code. Everything in AWS is restricted to the set of permissions that will allow it to do its job and nothing more. This is the principle of least privilege, and so we need to actually give the Lambda build step itself abilities to create resources or to be able to do things in the AWS environment. So we need to be able to have permissions to put the S3 objects out into the spaces that we've talked about. So we give permissions to the build stage to only add in objects into those specific areas that I talked about earlier. And then we need to be able to update the function code for that particular Lambda function. So we'll add that policy statement as well. At that point, we can build the pipeline and add the notification rules. As I mentioned before, this particular construct in AWS requires connecting a chatbot to Slack, which is necessarily a manual step. So we've done that in advance and provided the ARN here so that we can create the this Slack notification. And that's it. That's all the code, 130 lines of code for all the infrastructure to create a self-mutating CI/CD pipeline with Slack notifications. To get a sense for what those 130 lines of code do, we'll take a look at the CDK project, and we can run the CDK synth command directly here. When that happens, we'll see all the CloudFormation code actually pop up in the terminal. What we actually want to do, though, is see the file that it generates. So we'll output that to this cdk.yaml. And when it's done, we'll take a look. And that 130 lines of code has turned into 927 lines, 925 of CloudFormation template that's been generated. So that's a pretty impressive feat to pull off. We don't need that YAML file, so that was just to demonstrate what the CDK project is actually doing. When we git commit and git push, that CDK synth is happening within the build stage. If we want, we can actually look at a view of what the CDK constructs are that it's creating by looking at the CDK tab in the AWS toolkit for the IDE. That's creating a number of different objects. We've got our repository, our pipeline with the various stages that are in there, and the Lambda function, our Lambda stack, our Slack notifications. That's a way to view kind of where we're at within CDK and what we're creating, so you can keep tabs of that as you're creating your infrastructure. But keep in mind that throughout this demo, all that we've stayed almost entirely within the IDE. The only time that we've actually stepped out is to show things behind the curtains. Kate, for this entire process, didn't have to leave her IDE, and she didn't really have to touch any of the infrastructure, because in this particular case, it's not changing. But if she did, those changes would be done in a fairly succinct form using TypeScript. So with that, we're going to conclude our demo, go back to our slides.
So today we've seen Kate take an issue, reproduce that issue, write a test for that issue, develop a fix for the issue, and deploy that issue using VS Code, inspecting things through the CLI, and using the AWS toolkit for VS Code to be able to inspect things in the environment. But there's other ways that she could actually accomplish the same goals. AWS serverless application model doesn't have a CI/CD process the way that we were able to see with the CDK pipelines. However, if Kate already had a CI/CD process in place and she's developing a serverless application, one that uses API Gateway, Lambda, and DynamoDB, she could just describe her infrastructure using a YAML file that gets processed and can be pushed through CloudFormation. And it will fill in the details of the permissions that are necessary to be able to have API Gateway, Lambda, and DynamoDB talk to each other. AWS Amplify, if Kate were using or developing a front-end application or a mobile application, AWS Amplify comes with a complete suite of tools to be able to produce both a CI/CD and the application that she's writing. And then last, but certainly not least, AWS Cloud9 is AWS's browser-based IDE that could be provided for her to actually be able to author the code. It comes with the AWS toolkit pre-installed, but it also comes with a number of other pieces of software installed. To prepare for the demo today, I had to install a lot of software, and Kate, as she onboarded onto the team, would need to install all the same software. With AWS Cloud9, a lot of the software is pre-installed. For the demo today, I had to install Git, I had to install Visual Studio Code, Node.js, Python, the AWS CLI and TypeScript, the AWS SDK for Go, Go itself, and the Git remote code commit to do authentication up against a code commit repository. All these tools are actually pre-installed in the AWS Cloud9 IDE environment. So if she were just using Cloud9, she wouldn't have to go through any of those steps and multiple reboots. So to recap the demo today, we went through a lot of different tools. The AWS CLI version 2, the AWS CDK, the tools for AWS. This is the IDE toolkits that can be installed in VS Code, Microsoft Visual Studio, Eclipse, or any of the JetBrains family of IDEs. And then behind the scenes, we had Code Pipeline, Code Build, and Code Commit doing a lot of the heavy lifting of building, testing, and deploying Kate's code. And lastly, Kate was using the AWS SDKs to be able to interact with DynamoDB. I talked a little bit as well about AWS Cloud9, serverless application model, and AWS Amplify for front-end and mobile development, and the AWS tools for PowerShell. If you have any questions, feel free to reach out to me. I can be reached on Twitter @elurch or via email at emillurch@amazon.com. I thank you for your time,